Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, 6th SEM from the Department of Artificial Intelligence. Today I am going to discuss about the various topics which comes under the subject data science and its applications. So the contents we're going to cover in this presentation are the continuous distribution, the normal distribution, the central limit theorem, the p-values and the confidence intervals. So what is continuous distribution? Continuous distributions are the fundamental concepts in the data science and statistics representing a distribution where the variable can take any value within the given range. It is completely opposite to the discrete distribution, which are concerned with distinct separate values, and continuous distribution deals with the continuous data like temperature, height, weight, etc. So this normal distribution, it is defined by mean and derivation, standard derivation, and the symbols you can see here. Mean is denoted by mu, and standard deviation is divided by sigma. And the properties are the symmetrical around the mean. Mean, median, and mode are all equal. 68% of the data falls within one standard deviation of the mean, 95% within two, and 99.7% within 3. So what are the applications of this normal distribution? These are the commonly used in natural and social science to represent the real value variables with the unknown distributions. Next, moving on to the exponential distribution, which also comes under the continuous distribution. It describes the time between the events in a Poisson's process with a constant rate parameter and is denoted by lambda. So what are the properties what are the properties of exponential distribution? Is that is memoryless property that the probability of an event occurring in the future is independent of the past, which means that the event occurring in the future doesn't depend upon the past, and the mean and the standard deviation both are equal to 1 by lambda. So next, moving on to the applications, that is modeling waiting time or the lifespan of the object, such as the time until a radioactive particles decays, or the time until the customer service representative becomes available. So next, moving on to the uniform distribution, that is all outcomes are equally likely within the given interval A and B. Consider the given interval A and B, that is A is the initial interval and B is the limit. So this all outcomes are equally likely to be within the given interval. These are known as the uniform distribution. So what are the properties? That is, the mean is A by B divided by 2. Here they have given A by B divided by 2. The mean should be equal to A by B divided by 2. The variance is B minus A whole square divided by 12. So the mean should be A by B divided by 2 and the variance should be B minus A whole square divided by 12, and this defines the uniform distribution. So what are the applications? The applications are simple models which were outcomes within the range, as told in the definition, that simple models where each outcome should be likely to be equal within the given interval, such as stimulating of a fairly lottery draw. So next, moving on to the topic, CLT, that is central limit theorem, is a fundamental principle in statistics and data science that underpins many statistical methods and analysis. It describes the behavior of the sampling distribution of the sample mean when the sample size is large. So this central limit theorem states that the given a sufficiently large sample size n square, the sampling distribution of the sample means x dash will be approximately normally distributed regardless of the original distribution of the population, provided the population has a finite mean mu and the finite variance, that is sigma square. So here are the key points of the central limit theorem. That is a sample size, which means a theorem requires a large sample size, but large can depend on the shape of the population distribution. Generally, n should be greater than or equal to 30n should be greater than or equal to 30 is considered sufficient. Next comes the independence. The sampled observation must be independent. It should not be dependent on each other. Next comes the identically distributed, means each sample must come from the same distribution. So what is the importance of the data science? So the foundation of the inferential statistics, parameter estimation, hypothesis testing, and machine learning. These are the importance of the data science. So moving on to the next topic, that is the p-value. The p-value is a measure of the probability that an observed difference could have occurred by a random chance. In any words, it quantifies the evidence against the null hypothesis. So what is null hypothesis? It is referred as H naught H naught. The hypothesis that there is no effect or there is no difference. Next comes the alternate to this null hypothesis, that is alternative hypothesis, which is referred to as H alpha H alpha. The hypothesis that there is an effect or a difference. So mathematically, the p-value is the probability for obtaining the test result, at least an extreme as an observed result, assuming the null hypothesis is true. Let us take the example of flipping of a coin. We will get either heads or tails. So this is how it works. This is how the p-value works. It depends upon the hypothesis, that is the assumption. So here I am taking an example to explain you about the p-value. Suppose a company wants to test if a new marketing strategy leads to the higher sales than the current strategy. They collect the sales data from the two groups, one using the current strategy and another using the new strategy. Okay, so now let's formulate the hypothesis, that is H naught H naught, that is the null hypothesis. The mean sales of the control group equals the mean sales of the treatment group. Next, the alternative hypothesis, that is H alpha H alpha. The mean sales of the control group do not equal to the mean sales of the treatment group. Here, the control group refers to the current strategy and the treatment group, it refers to the new strategy. Next, we will choose a significance level, that is, we will take a assumption, that is alpha 0.05 and even here alpha is 0.05. Next, collecting the data and compute test statistics. That means perform a two-sample t-test and calculate the test statistics. Okay, now we will compute the p-value. Assume the p-value of the test is 0.03. Next, make a decision, that is, since p is equal to 0.03 is lesser than or equal to 0.05, the probability is equal to 0.03, which is also less than 0.05, then we will reject the null hypothesis, that is H naught H naught. The company concludes that there is a significant evidence that the new market affects the sales. Understanding and utilizing continuous distribution is crucial in data science for accurate data analysis, modeling, and decision making. They provide the mathematical foundation for many statistical methods and machine learning algorithms. The central limit theorem is a cornerstone of statistical theory and practice in data science. It enables the data scientist to apply the statistical method and draw the meaningful conclusion from the data, even when the underlying population distribution is unknown, by ensuring the normality of the sampling distribution of this sample mean. The central limit theorem provides a solid foundation for a wide range of analytical and inferential technique used in data science. So the confidence interval, as we discussed, it has a powerful tools in the data science, offering insights into the precision and reliability of streams. P-values are the fundamental tool in data science for hypothesis testing and statistical interference. Like we took the example of a flipping of a coin, and they help the quantity evidence against the null hypothesis and guide the making the different application.